Welcome to New Racing Tutorials. My name is Lloyd James, and in this set of tutorials we'll be going over the use of ANSYS CFX for simulating something as complex as the whole car. To start this, we'll look at the geometry aspect of the simulation. In the team, car geometry is created in Creo. Most people work out of the EV2 CAD directory to create their car geometry. The difficulty with that is that it's not uncommon for something like this to occur. This can be caused by all manner of things and can also be difficult to fix. For this reason, and the fact there are so many components in the main assembly that ANSYS does not handle very well, we'll work in our own environment. For this, we'll take the chassis assembly. We will open this separately and take a shrink wrap of it. To do this, we take the chassis as a starting point. We'll open it on its own now. Now we have the chassis open, we'll create a shrink wrap. This is done through File, Save As. We select shrink wrap as our option and a location for it to save. We name it appropriately and we select OK. We then use Merge Solid as this reduces the model tree complexity later on. Now the shrink wrap has been created. We then open the shrink wrap. As you can see, some parts have failed. This is most likely due to my computer not being 100% happy with the main assembly at the moment, so it is advised to do this on a computer that is fully functioning with the main assembly. Even this rough outline of the chassis is enough for us. We'll then use this to create some geometry and go from there. Geometry is created as normal for Creo, and additional planes can be added to start geometry creation from where desired. The goal here is to make this chassis into a rough solid replica of the car to put into ANSYS in a single part. This can be done over the top of the chassis or in a separate file using the analysis tool to determine distances between locations. The first step is to take a measurement of the front rectangle of the car. This vertical distance is 305 millimeters and this horizontal distance is 355. To both of those, we add the diameter of the tubes 25.4. The other measurement we need is the length of the car. This measurement is 24.05 plus the diameter of the tubes. We can now create our first extrude. We have a rectangle that we set symmetric for ease of measurement. We can then type the equations we want directly into Creo. Now we have a rectangle, we can extrude this. We extrude this rectangle the length of the car. Now we extrude the length of the car. This is a good starting block that everything else can be added until the chassis more or less resembles the chassis model in Creo. This can also be done bottom up. Here's one I prepared earlier of EV2. EV2's is relatively simple to create due to the simple nature of the EV2 geometry, and while there are some features missing, it is essentially the same, and this is good enough for the simulation. Note for when creating the wheels, it is recommended to extrude something into the wheel and then put a round on that to ensure that the wheel has a contact patch on the ground and there are no points where the mesh can go to infinity. It is at this point where wings, nose cone and under tray would be attached. However, at this stage, those parts have not been created and thus will not be demonstrated in this tutorial. A domain can then either be created in Design Modeler in ANSYS, as was done in Mech 3780, or in Creo. To create a domain in Creo, generate a large box that is bigger than the car. This is a demo box that is quite small, however your box should be at least 5x of the car in most directions. To perform a Boolean operation, select Get Data and Merge Inheritance. We now select the part that we want to remove from the box and we do the component placement up here. The component placement is very similar to that of an assembly, such that you select your desired plane from this location and select the point on the box from this one. This is done until the model is fully constrained. Now this is complete, tick OK. We now select the version of merging that we wish to do. We wish to remove material with the car. We select OK. Now there is a portion of the car that is removed from the box. Some fine-tuning may be required to ensure that all planes line up as desired. That can be done with the sketch location of this extrude. Now we have some geometry in Creo, we import it into ANSYS. To import geometry, we simply select the geometry that we would like and then right-click and edit in Design Modeler. Select the Generate button to attach the geometry, and once this is complete, we can view the geometry. To enable parameters, scroll down to the bottom of the geometry selection in Attach 1 and select the checkbox for parameters. These parameters can now be changed in ANSYS, as seen here. Changing these parameters will feed this value back into Creo, so it is critical that Creo is still open for every time a parameter needs to be changed. That is all for attaching geometry. The next episode will be on the meshing of the geometry.